Bismillahirrahmanirrahim. Our today's topic is fodder preservation techniques or fodder conservation techniques. And by conservation, we mean to preserve the fodder for future use of animals. And conservation means preserving the fodder for animal use when the fodder is short in during slump period. We all know that during severe summer and severe winter, there is a shortage of fodder. So in order to cope up this shortage of fodder, we need some conservation or preservation techniques so that the animals they don't have to face this shortage of fodder. So I would generally, in my opinion, basically the preserved fodder is of two types. Is the one which has a higher moisture percentage of moisture percentage, and which one is having a lower moisture percentage. For example, if we use the silage, generally speaking, we have two techniques for the preservation of fodders. The first one is silage, which gives us the preserved fodder at a very high moisture content level. Whereas another technique for the preservation of fodder is hay making, which gives us, no doubt, which gives us fodder at a lower moisture percentage rates. So the question here is that I will be discussing today with you why preservation of fodder, what are the reasons for preserving the fodders, and I will be discussing with you these two different methods of preservation of fodders. Like So the first question is why the preservation of fodder is needed, or why conserve? First of all, fodder is a natural feed for ruminants, and it is very essential for human function. Most of all, it's a cheap source of nutrients for these ruminants, and it gives us a low. It lowers the production cost of fodder. Also, there are some latest techniques, new technologies available, and so that the animals could be provided with fodder under severe calamities or under slump periods of the year. Also, these techniques they empower the farmers to provide quality roughage throughout the year. So, we need to, preserve the silage. So, we can say the objectives of these preservation methods are to preserve the feed when it is available in excess, and to maintain the optimum nutritional value of the fodder. And third one is to shift available feed from present to the future. Also to move feed from one location to another location. And in addition to these benefits, we can also help or provide assistance in pasture management. So these are some benefits or why we, go for the preservation of fodder. So I already told you that hay and silage are the main methods of preservation of forages. So hay is preserved by drying, and it will generally keep while it is kept dry. And silage, it involves natural fermentation, which produces lactic and other acids, which pickle or preserve the forage. Um, if we talk about direct cut silage, the percentage of moisture is 70% plus moisture in the direct cut silage, while wilted silage gives us 60 to 70% of moisture in this fodder. Hay, I already told you, has the lowest moisture level, that is 15 to 18%. Coming towards the methods of preservation, silage is an important part of feeding regime of animals, whether these animals are dairy animals or beef or fattening. In the dry tropics, where a longer dry season prevails, feed shortage in dry season is quite serious and it becomes a major and common constraint in animal production. And moreover, hay making, it's not always a good solution, and silage is seems to be a feasible alternative. Silage making is practiced to store and preserve green fodder when it is available in excess or abundance for later use during scarcity or slump period. Therefore, the production is less dependent on specific weather conditions and can be extended to a great variety of forage. So, what is the principle of silage? I would say anaerobic condition is foremost requirement for silage making. Um, in detail, after forage crop is cut, loss of nutritional substance it starts due to activities of different enzymes. So main objective is to stop enzymatic reactions and minimize loss of energy, protein, and other nutrients. This silage making it allows lactic acid bacteria to grow, which converts sugar into lactic acid, which is a strong organic acid. So as the pH declines, the enzymatic action is slowed down. And at about 3 to 4 pH, most degrading enzymes are inhibited, and the growth of lactic acid bacteria is also inhibited. Chemical composition of a forage crop or agro-industrial byproduct, it's important. So selection of crop for silage making is based on some basic criteria, like selecting those crops which have high fermentable sugars, low level of proteins, and low buffering capacity. So if the moisture is high, it leads to butyric acid production. So if we talk about the phases of silage, there are four phases in which silage making is complete. Phase one, respiration, which degrades the plant nutrients in the presence of oxygen. It's almost the first 2 days, 1 or 2 days. And then starts the early fermentation process, which is the phase two, in which acetic, formic, and other organic acids are produced due to the growth of facultative aerobic bacteria in the presence or absence of oxygen. So it also takes next 1 to 2 days. The phase three is lactic acid fermentation, in which bacteria that are strictly anaerobic, they start to multiply rapidly in the absence of oxygen, and it takes almost 14 days. And the last phase, that is known as stabilization phase, in which further degradation is inhibited as bacterial and fungal growths they are checked. So these four phases, I would repeat these four phases again. The first one is respiration. The second one is early fermentation, and so it takes 3 to 4 days, early 3 to 4 days. But after early phase fermentation, lactic acid fermentation is the third phase where anaerobic bacteria they start to multiply rapidly in the absence of oxygen. And in the fourth phase, and the third phase takes about 14 days, whereas in the last phase, which is stabilization phase, where further degradation is inhibited because the bacterial and fungal growths these are checked. So these were the phases of anaerobic fermentation for these silage making. So what is the process? So I mean, how we should be making the silage. First is harvesting of fodder. Then we will test the fodder for moisture content, which must be 65 to 70 percent, and it's ideal. Even if it's I mean 60%, it's also okay. Then the forage chopping in a way that the size of the job is 1 to 3 centimeter. Then, in the next step, we spread this chopped fodder to make a bed of 2 feet height in silo pits. And after that, we compact the forage as tightly as possible with tractor, with hand roller, or any other heavy object in order to remove any of the gases and trapped. After that, this first 2 feet layer of pressed or compacted chopped fodder, we sprinkle the molasses over it. And then again we repeat to form another layer in the silo pit. And then we sprinkle molasses. And then at the end, when the silo pit is completely filled up, we seal the pit airtight and press with heavy objects like bricks or tires. So we maintain this sealing for 45 days, 40 to 45 days. So once silo pit is open, it should be finished within 45 to 60 days, around 1.5 to 2 months. So how we can, I mean, judge the quality of silage, whether it is good or bad? First is the color. The color must be pale yellow. Then is a smell, sweet and sour flavor. Like I mean, we sometimes we smell from some biscuits, uh, and then the taste should be sour. And when we, I mean, squeeze in hand and release, it breaks into two. So that means the quality of the silage is very good. So, if the color of the silage prepared is dark brown and green, then the use of this silage is prohibited. I mean, it shouldn't be used for animals. So, I think I have discussed the benefits of this. Silage making, the process, the principle. Um, so that was about the silage making. Uh, the next part is about hay making. I have discussed with you in detail the silage making. What is silage? What is the principle of silage? The benefits of silage, silage making process, and all these details. Let's start the hay making process. So the basic principle of hay making, it's to reduce the moisture concentration in the green forages sufficiently as to permit their storage without spoilage or further nutrient losses. So the moisture concentration in hay, it must be less than 18 to 15% at storage time. So hence crops with thin stems and many leaves, these are better suited or suitable for hay making as they dry faster than those having thick and pithy stems and small leaves. So there are different steps for hay making, in which the first one is harvesting, curing, and baling of hay. Leguminous fodder crops, these should be harvested at their flower initiation stage or when crown buds start to grow. So while grasses should be harvested at their pre-flowering or flower initiation stage. And harvesting, it should be done preferably when the air humidity is low. So the harvested forage, it should be spread in the field and raked a few times for quick drying. The dried forage, it should be collected and baled when the moisture concentration becomes lower than 15%. So baling the hay helps in storage and requires less space. So we normally use the natural drying under the sunlight, but there is another method of drying that is known as artificial drying. So field curing is mostly done during bright sunny days, which causes bleaching of the forage. That means the natural color of the forage is lost, and loss of leaves due to shattering, because when it becomes dry, the leaves they shatter down. So nutrient may also be leached out if the forage is exposed to rain. So to avoid these losses, forages can be dried in barn by flowing hot air through the forage. Its main benefits are that nutrient losses due to leaf shattering and bleaching, these can be avoided, and that the forage can be harvested irrespective of the prevailing weather conditions. Although artificial drying, it results in hay quality approaching that of the fresh forage. It is expensive and beyond the reach of small and marginal farmers, especially under our field conditions. So there are some losses in haymaking. For example, monsoon grasses and fodder crops, they come in flowering stage during August and September. So fast lignification and translocation of sugars in these crops occurs after this due to high temperatures, resulting in a rapid decrease of the digestibility. Considerable losses occur with the monsoon grasses because they are not harvested and preserved at the stage when their, digestibility is fairly high. So this may be due to the prevailing weather conditions and the lack of interest and skills for proper preservation and storage. And preservation of any surplus fodder, it can be beneficial during a scarcity period. So uh, there are different steps which can, things happen. For example, respiration by living plant cells after harvesting, it occurs at the cost of carbohydrates. So the sugars, carbohydrates which are present in the fodder are so lost. So, however, this loss is it's almost nominal and as compared to losses due to shattering, leaching, and bleaching. So, during the process of drying and curing, there are losses due to shattering and dropping of leaves, which are the most nutritious parts of the plant. So legumes are particularly they are sensitive to leaf shattering. So leaching is caused by rain during the dry period of hay, through which the soluble nutrients they are lost. And continuous and excessive rainfall, it may result in large losses due to decomposition and mold growth. And another source of loss is bleaching of hay due to its excessive exposure to sunshine during the drying and curing process. It causes losses of nutrients, particularly the carotene. High moisture content at the time of storing, it may lead to to fermentation and molding of hay, because this kind of fermentation is aerobic. It happens or occurs in the presence of oxygen. That is why it's not required. So if the hay is moist at the time of storing, fermentation sets in with a rise in temperature. So the overall loss of dry matter and nutrients, it may range from 15 to 50%, and it may lead to the development of mold, fungi, and undesirable bacteria. So our high moisture content at stacking time, it results in fermentation of forage and a rise in temperature, resulting in overall dry matter and nutrient losses. I already told you the range, which is 15 to 50%. So a moisture content above 15% may also lead to the development of mold, fungi, and undesirable bacteria, which make the hay unsuitable for animal consumption. So that is why hay making, silage is preferred over hay under field conditions. So thank you very much. I think that was all.